Hi, Branda's here, and I'm going to be teaching you how you can go about memorizing the unit circle in the way that I think is like the most efficient to do it. So I feel like when people first see the unit circle, they're sort of just like, how am I supposed to go about memorizing all these numbers? Like, what the heck is going on? And I feel like when like our professors show us the unit circle, I don't know. I think it's important that you kind of figure out that you can break the unit circle apart. And you don't need to memorize all these 12 numbers. You just need to memorize 3 of them and then flip them around and rotate them. And that makes your life a lot easier. So in this video, I'm just going to show you how you can memorize 3 and how you can use them to get all the other angles that you need. So let's get started. Stop. So here I have the only 3 triangles that you really need to memorize. Okay? So here we have the, why did that happen? We have the 30-degree triangle where pi over 6 is 30 because, you know, 360 is 2 pi, 180 is pi, 90 is pi over 2, etc., etc. You just keep dividing it until you get a 30 or you get a 60. We have our 60-degree right here. Oops, sorry, that's not 60. It's 45-degree right here, and our 60-degree over here. Okay, so you just need to make sure you know. Okay, when the 30-degree angle, since it's a pretty small angle, it corresponds to a pretty small side, right? So that's just what the triangle is, and the other side is going to be a little bit larger. And for all these triangles, the hypotenuse is 1 because we're talking about the triangle in terms of the unit circle. So whenever I'm talking about this pi over 6 triangle angle, I'm talking about the triangle that's formed by that angle if the radius is 1, which is the unit circle. So like this triangle here, this triangle here, this triangle here. And the reason why we only need to memorize 3 is because if you like look at the other quadrants, these are all just repeats of the original triangles, just like the x here is going to be negative, and the x and y here are negative, and the y over here is negative. So they're really all the same thing. So you just need to make sure that you memorize these 3 triangles and your life should be easier. But even just memorizing these triangles, we have our trig functions. So let's just go through them. So we have the sine function, and it's a function on the angle. We have the cosine function on an angle, the tangent function on an angle. And what does that mean? So you know you have the saying, so katoa. The sine function, so, S-O-H, of any theta is going to be the opposite from that angle, the side that's opposite, the length of the side that's opposite of that angle, over the hypotenuse of that triangle. The cosine is going to be ka, which is the adjacent side over the hypotenuse. And the tan, which is the toa, is going to be the opposite side over the adjacent side. So, okay, cool. So let's just try and compute these angles and see like what they mean. Alright, so I'm just gonna go through one triangle pretty slowly, and then once you get the hang of it, the rest of the triangles should be like easy breezy beautiful. Okay, so alright, so I'm just gonna go through each trig function of this triangle, the pi over 3. Alright, so I'm gonna say, okay, what's the sine of pi over 3? No, I like writing it a little better. What is the cosine of pi over 3? And what is the tangent of pi over 3? Okay, so we know the sine is the adjacent, so nope, it's the opposite over the hypotenuse. Okay, which means if you have this angle, the opposite side is going to be this one right here, and the hypotenuse is always going to be this long side. Okay, So the opposite is root 3 over 2, and the adjacent is 1. So the sine of pi over 3 is just root 3 over 2. Ooh, we're good. Okay, now we have the cosine. The cosine is the adjacent over the hypotenuse. Okay, and that means, let me just erase this real quick. The adjacent side is always going to be the side that's right next to the angle, but isn't the hypotenuse. So this little side right here. So, and the hypotenuse is always, our little 1. So the adjacent over the hypotenuse is the adjacent being 1/2, and the hypotenuse is 1, so it's just 1/2. Bang, we're good. Now the tangent is the opposite over the adjacent, the TOA in SOHCAHTOA. So the opposite angle is going to be root 3 over 2, and the adjacent angle is divided by 1/2, which is equal to root 3 over 2 times 2 over 1. Those two cancel, so you get root 3. And that's the tangent of pi over 3. So, also, if you notice, okay, well, the tangent is the opposite over the adjacent, right? How can I say this? Basically, all right, so you have the opposite over the adjacent is tangent, right? Well, couldn't you write this as the opposite over the hypotenuse? No, what the fuck? Yeah, times the hypotenuse over the adjacent, right? So those two cancel, right? But what is this? This is also equal to the opposite over the hypotenuse divided by the adjacent over the hypotenuse. And what are these two? It's the sine divided by the cosine. Crazy stuff. So any sine of theta divided by the cosine theta is the tangent of theta. Whoa, math, wild. Okay, I don't know, that's just a little tangent. Gotcha. Okay, okay, so now I'm gonna go through the other triangles, and we're just gonna do like a speed round since we have the hang of it. We can keep going. We can just eyeball it. We don't even need to do math. Maybe we do. We'll see. Okay. So let's do pi over 6. All right. So speed round. Pi over 6. The sine of pi over 6 is going to be the opposite over the adjacent. So it's just going to be 1/2. The cosine of pi over 6 is the adjacent divided by the hypotenuse. So it's root 3 over 2. The tangent of pi over 6 is going to be the sine divided by the cosine. So it's 1 divided by 1/2 divided by root 3 over 2, which is going to flip around and give you root 3. And did I do that wrong? Probably. Yeah, it's 1 over root. This is why you do math. Let's just do it out. 2 over root 3 gives you 1 over root 3, right? Okay. Now we go to pi over 4. The sine of pi over 4 is going to be the opposite over the adjacent, 1 over root 2. Cosine of pi over 4 is going to be, again, because this is an isosceles triangle, so these two sides are the exact same. The opposite and the adjacent are the same, so the cosine and the sine of them are the exact same. So the tangent of pi over 4, again, because the adjacent and the opposite and the adjacent are the same, it's just 1, because it would just be 1 over root 2 divided by 1 over root 2, which is 1. So we speed rounded it. It's great, amazing. So that's great.